Please proceed.
Okay, thank you.
Yes.
First of all, I'd like to thank Professor Ranjan Bala sir and Professor Swain sir and my dear friend Dr. Chandra Prasad Das sir for giving me opportunity to explain about my thought process, that is the time series analysis. So I will not take more time about who am I and what actually I'm doing the research. I've come to my business, that is why time series and why you are here. So basically there are three types of data generally we are using in our econometrics. One is cross-section data, another is time series data, another is the panel data. So in cross-section data, we already have, it means we have collected the variables or the different period of times. For example, we are using SPSS for that to analyze the model. Suppose I want to find out the behavioral of the employees of the behavior of the HCL employees based upon the attitudes, their learning, their educations, income. So all the information about the populations with some period of time, it is cross-section data. Where we apply the econometrics, that is, we apply the multiple regression model, but then we check the autocorrelation, multicollinearity, that is different thing. So we can use the cross-section data into the spaces also. Today we're having a time series data where our objective is to find out that different data or that variables with different period of time. I will explain what is time series data. Then tomorrow we are having panel data, is the information about the same population of different period of times. Time series not only applied in econometrics or finance, it may be applied for forecasting or election. You can apply with supply chain. You can apply also advertising. You can apply also web traffic. So you can apply in science, engineering, everywhere you can apply time series. Because what is the objective of time series? There are three things. First, understand the behavior of your data. Second, understand the trends of your data. Third, to forecast your data. When you say forecasting, because forecasting is the major things what we're going to discuss about time series. When you say the forecasting, there are different concepts coming around. First, whether the forecast of next year is based upon the previous year, or whether forecasting of the next year is based upon the residuals, or it is related to other terms. So we'll discuss about univariate, bivariate, and multiple time series within next series. So I welcome to all of you for this time series data. We know it is very difficult to predict. If you predict time series data and 100%, then everybody will be millionaire, because if you predict the stock market, if you predict the share, if you predict derivatives, then we all will be millionaires. Okay, there will be some error will be there, and we'll try to find out the error should be minimized and error should not be maximized. Now the question arises, when the data is random, when data is different fluctuating, when data is volatile, how to estimate your information, how to estimate the variable different period of time. So my agenda will be, I'll talk about time series, then I'll switch about the stationary, non-stationary through e-views, because what I am interested, I will explain everything through e-views, so that every concept I'll give some theoretical overview, then I'll explain about the through e-views, because my objective is to sensitize each and everything, so that when you will do the research, you can find out what exactly you will be do in your futures. So I'll talk about concept of time series, then I'll talk about stationary, non-stationary. I'll explain about ARIMA model through reviews. Then I'll explain about Granger Causality model through reviews. That is, then I'll go for VAR model, then arts and graphs. Let's discuss about one by one what exactly I'm talking about. So when you take a concept time series, I will explain about what is stochastic time series and what is realizations. When I come to stationary, I will find out whether when the data is fluctuating like this, which is very difficult to forecast, so how we will convert this non-stationary data into stationary so that we can predict with our futures. When we talk about ARIMA, ARIMA is a concept of three different words. One is called AR, another is called I, another is called MA. AR means autoregressive, where you can say that the YT means it depends upon the F of YT minus 1. Means that today's price depends upon yesterday informations, or you can say that YT minus 2, YT minus 3. So it means what we want to predict, whether today's information or today's sale is depends upon, or today's stock price depends upon the past observations of 1 leg or 2 leg or 3 leg. Leg means 1 T minus 1 is 1 leg, T minus 2 leg. I will explain one by one. Then sometimes our information or forecasting depends upon moving average. It means residuals also. So it means that today's price depends upon the residual of the first leg. So what I will do, I will explain about how we can predict about sales or stock price or derivatives or the help of autoregressive. Autoregressive means based upon its own leg and moving average means based upon its residual legs. So then we'll go integrated, how to find out the best model to predict. I will explain ARIMA. Then I will switch over to Granger causality. I want to find out whether there is a relation between X and Y. It means if X is GDP and Y is your inflation, I want to know whether inflation is caused to GDP or GDP is caused inflation. So when you say the Granger causes, whether GDP is causes to the inflation or inflation is caused in GDP, I will use the Granger causality model. Then I will switch over to the VAR. That is called vector auto regression model. Again, there are two things. I will find out the relationship between two variables, GDP and the inflation, and also I want to find out the relation between GDP and its legs. Means GDP T minus 1, GDP T minus 2. I want to find out the relations between GDP and inflation and GDP and its leg and inflation leg to find out what should the better predicting variable so that our error should be minimized. Then I'll go for the arch model. Arch model means when there is a volatility, for example, this is the volatility. It's another clustering the volatility. When the volatility is there in residual, how to do the model? Because when there is a volatility in residual, for example, this is the one, now this is another one, this is another one, this is another one. Now see, this is the clustering volatility. When this clustering volatility is there, then how to forecast your model. So I will discuss about the concept. There are many things are there. It is called error correction model, vector error correction model. Then where different concept is there. But I am to focus on the time series, stationary, ARIMA, Granger causality, VAR, and arch model. So when you talk the stationary and non-stationary, I will use the three things. One is called Coriologram, and I will do the Init root test, and I will explain one by one. So this is my agenda. Basically, I'm talking about the forecasting with the help of its own leg and its residual leg, relationship. When there is a relationship, I will apply Granger causality. When I find out relationship, the variable and its leg, I will go by VAR. When there is a clustering volatility, then to measure that volatility, I will go for arch. And but what the most important thing that data should be stationary. I will explain everything within next few seconds. So these are different terms will be used in our model. I will share this PPT to all of you. Don't worry about the PPT. Whenever any snapshot, you take the snapshot also. We'll use the word stationary, linear, seasonal, univariate, non-stationary, non-linear, non-seasonal, and multivariate. These are the 5-10 terminology everybody will use in time series. Most important is stationary, non-stationary. That is a basic thing that every researcher should know about what is stationary and why required stationary. Let's talk about time series concept. Suppose now see, there are two different times. Am I audible, Chandrika? Hello? Okay. You know.
Yes, you are audible.
Now see, there are two different time series. One is declining sometimes and increasing, and another is some clustering volatility. Clustering is there, like one clustering, another clustering, another clustering, another clustering. Now the question is, when there is a clustering and the trend is different, and when seasonality is there, how to predict? Because I cannot predict what should be 2009. It may be here, or it may be here, or it may be here. I don't know whether which will be, whether it come to X1 or X2 or X3. So it means this is called non-stationary. Means that non-stationary means that the graph is not constant to its mean and variance. I'll explain about that. This is non-stationary means it is some trend. It does not change in mean value and variance value. Now this is called stationary data. Now here what happened? What happened when this is mean value? The graph moves from upward and come to again mean, again come downward, come to the mean. So it means it is reversal with mean and ST. So there is some deviation is a constant mean and it is around reverse with the mean. What question arises? Now there are two types of information. One is this one. Can you predict anything? I can say no. I cannot directly predict this information because information is stationary. I cannot predict because I don't know what will the future, because there is some volatility is there, some trend is there. I cannot predict. So first thing is that you have to convert your non-stationary into stationary through like this. When the data will convert into stationary, then here I can predict certain things. Now the question arises, how to predict? Can you apply autoregressive? Can you apply moving average? Can you apply both? Can you apply arch? Arch means, now see, this is a clustering volatility. This is some clustering volatility are there, and I want to remove this clustering volatility so that if there should not be any heterogeneity effect, then only I can apply arch model. And if I apply Grach model, where you will use the mean and the variance equation both to forecasting, I apply the Grass model. Or I can find out, is there anything with relationship between the YT and YT minus 1? It means the information of present information, which is lag information. So these are the different fundamental concepts we're going to use in our model. So basically, every researcher, please remember, whenever you do the time series, first and foremost thing is that you convert your data or your time series information from non-stationary to stationary. I will explain how to do that. Now, what is the time series? Time series means realizations of stochastic process. Stochastic process means it's random, and every realized observation is a stochastic process. And that when you take the mean value of that, we will got the time series data. And with the help of time series forecasting, we can do two things: we can prepare dynamic modeling or can time series modeling. So let me explain. There are two different terms we're using in time series. One is called YT, and another is called Y bracket AT. What is different between these two? Because please remember, this is very important. When you say that most economic data are collected at discrete point of time, we usually use notation YT when discrete. When it means Y1, Y2, Y3, Y8. When it is a continuous point of time, we say it means if it is a continuous, we say it is YT. Discrete, it is, for example, this is called discrete time series. This is called continuous time series. Suppose I want to find out GDP of 1981, 82, 83, 84, 2019. So how I will write? I will write like this: GDP 2008. This is called discrete. If I say GDP 2008, GDP bracketed 2008, this is called continuous. So generally, we are using discrete time series in our analysis. We can also use continuous time series. There is no problem. But please remember, this is called discrete. This is called continuous. So when I will use the discrete and continuous, please remember, when it's a discrete, it is a Y subscript T, and what is Y bracketed T in continuous. So now what is a stochastic process? Because everybody says that what is time series, and we all will say that this stochastic process. Suppose I say that GDP of 2009 is 2,873 billion. What does it mean? It means if in a quarter, suppose month January 1 to January 31, 1 में data यहाँ पर आया, 2 में यहाँ पर आया, 3 में यहाँ पर आया, 4, 5, like 6, like this. So when you calculate the average of all these things, I got another one value. It's called X1. So I can say that this is the stochastic variable of this particular quarter. So it means 2019 quarter, I have to find out 2873. It means this is the mean value or stochastic value of all the relation. For an example, see, this is the 0, 1, 2, 3, 4 period. Now, if you see, this is the average of this quarter, this is the average of this quarter, this is the average of this. This is a random distribution. It means from particular quarter or particular year, lot of informations are here, but we will take the single value of that. And that is the stochastic value, that is the mean value of all the things. When you add all this value, we got time series. It's nothing but a time series. Okay. Now, like this, we have different informations. When you use this information, and we call it a time series data. Now, this is a mean observation. And when you use this concept, when this terminology, I will got a time series data. Now, the time series data, there are two things. One is called stationary, another is called non-stationary. Now, this is non-stationary because it changes. It has a trend. It is, but it is not change with its mean value and variant value. This is also non-stationary. So the first and foremost thing is that, and all our stationary data, whether it is a BSc Sensex, weekly Sensex, daily Sensex, monthly Sensex, and quarterly Sensex, all are non-stationary data. The first and foremost, I cannot predict anything about this data. So I will convert this data into stationary. There is a different process to convert into stationary to check the stationary, and the process is called transformation. Transformation is one of the process for stationary. You can find out the first differences. You can find out the second differences. You can convert into the log value. You can convert into price into return value. Whatever you have to convert, and then you convert into the data into the stationary. And from that conversion data, we will use the forecasting. Now, this is called stationary data. Now, here what happened? This is the mean value, and when the data is coming under with the mean and variance is constant. And it means now the price data is converted into return data. When you convert price into return or log return or simple return, automatically it converts into the stationary. This is the stationary data, but here the problem is that I cannot predict this information, this stationary also, because I have seen a lot of clustering volatility is there. So when there is a clustering volatility there, if you want to predict, I cannot use directly ARIMA model. I can use the model is called the arch model and the Gratz model. The arch model means I'm having the mean value informations, and if you have to take the variance and exogenous variable, then I will go for the Gratz model. Now, first of all, so there are two different terms when not stationary, what is called white noise, if it is zero mean. Second, there is a variance will be finite, it is uncorrelated and identically distributed. It's called the IID. So it means the series will be white noise or stationary if it is zero mean, finite variance, series uncorrelated and identity distribution. Now, what is stationary? Please remember, this is the meaning of stationary. In mathematically, I can say, or econometrically, I can say, the mean is a constant, variance is also a constant for all times, and the covariance is also be constant. So, what is stationary? A time series is said to be stationary if its mean and variance are constant over time, and the value of covariance between the two periods depends only the distance or gap or lag. Means, I want to say that there are three things. One is called label, another is called first difference and second difference. Please remember, my dear participants, sorry, there are a lot of professors there. I cannot say dear participant. Dear professor, please listen. There are three things. One is called label, means the information you are having, and first difference means you convert yt minus 1, yt minus 1, yt minus 2. So when you say the one leg or the difference of one leg, it is called first differences. So then second difference means yt minus 1 minus yt minus 2, yt minus 2 minus yt minus 3. One thing should remember, don't take many differences for converting to stationary, because if you use third level or fourth level or fifth level to find out the stationary, then you will lose the degree of freedom. We always try to, if the better is that if it is stationary with the first level, level is good, but level cannot be not find out. It will be first difference or second difference. There are two things we'll use in the stationary. One is called Init root test. I will explain how to. So if it is Init root, means it is non-stationary. If the data is Init root, okay, it means then it is non-stationary. If it is no Init root, then it is stationary. I also can say that we'll check the random walk. Random walk means, suppose this is a walk like a person. This is random. So I don't want to say that this is a random walk. I want there should be no random walk and there should be no Init root test. If there is no Init root test, then we can say that data is stationary. And for that, there are three different methods will be used. One is called Dickey-Fowler test. Another is called ADF test, that is augmented Dickey-Fowler test. And third one is called Phillips-Perron test. So let me explain about one by one through the e-views. In Dickey-Fowler test, what is our objective? The error terms are not correlated. Now, augmented Dickey-Fowler test, I will say that error terms are correlated, and Phillips-Perron test, where the error terms are correlated. I will explain this with the help of e-views. So let me explain about e-views. Is it visible now, Chandrika ji? Is it visible?
Yes, sir, it is visible.
So now see, I am using one data that is called gold price, and this I have taken the simple information. Data is the gold price and return, and that is a oil price. I want to find out whether the data, if you see, this is the gold price of different period of time, 2003 to different gold price data. And if you are say, if you click both the things, gold price and oil price, if I say the open group, I see this is the gold price and oil price of different period of times. So then first of all, I want, whenever you do any time series analysis, first thing is that you have to draw the graph and see whether it is stationary or non-stationary. So what I will do, I will just click the gold price, just write down the format, just click the gold price, go to the view, there is a graph, and I want the line graph. Now you see, can you say it is stationary? Just one, can you participate so that I will understand कि मेरा आवाज भी जा रहा है and लोग attentive हुए. Chandrika is just to say yes or no. Do you think it is stationary? I think it is not stationary. I cannot predict the gold price of next 2021, 2022 because this is non-stationary. Similarly, if I say the oil price, if you go to the view, then I will go to the graph. I will go to the graph, line graph, and I see this is also non-stationary. Now the question is, can I predict anything, any forecasting through this data? Perhaps not. So first and foremost thing is we'll check that whether data is stationary at level or first difference or second difference. So we'll use two things. First, please write down, we will convert in init root test. मैं आपको पूरा बताऊंगा कि thumbs rule, so that I don't, because within 1.5 hours I will try to convert maximum thing with the thumbs rule, so that if people are ignited to understand the concept. So first I will show the gold price. Click gold price. I'll go to the quick, just write down the quick. There is called series statistics. Then I will click init root test. The init root test, what is my price data? Data is the gold price. So I will write gold price. Or let me talk oil price. Oil. Okay. Now see here the different types of tests. One is called ADF, Dickey Fuller, Phillips Heron, KPSS test. What we'll use ADF test. First we'll check the level, whether the data, because suppose if you do not have any graph, you can also check whether data is stationary or not. Click the label, click OK. Now, what is the null hypothesis? Is it measurable?
Yes, sir.
What is null hypothesis? Oil is init root. So it means we have init root means non-stationary. Agar root init hoga, so it will call it non-stationary. So null hypothesis is that the oil data is non-stationary. What is the p value? If the p value is greater than 0.05, it means this null hypothesis is accepted. It means oil is init root. Means oil is non-stationary है. अगर p का value 0.05 से above है, we cannot reject null hypothesis. We accept that oil is init root. It means oil has non-stationary data. Now, I cannot use this data for my further research. What I will do, I will check whether this data will be stationary at the fast differences. Now, you will say, what is fast differences? Fast difference means you have to find out the difference of the yt minus 1, yt minus 1, yt minus 2, yt minus 2, t minus 1. It means the difference between the current price and its previous price. When you call it that series, it is called fast differences. In fast differences, the first variable or first point should be omitted. So now we have proved that this oil data is non-stationary because it is init root, because the p value is greater than 0.05. So what I will do now, I will check, go to the quick, go to the group statistics, series statistics, click the init root. Now I write down oil. Now instead of oil level, I will check the fast differences. Means I will check that if I transform this variable, can it be stationary? I say okay. Now see, p value is less than 0.05. It means null hypothesis is rejected. It means the oil has init root is rejected. So we can say that the difference of the oil is stationary. Now अभी मैं बोल रहा हूँ कि oil का first difference stationary आ गया. I have to see in the graph. Can it be stationary? Go to the view, go to the graph. Now this is the original graph. This is oil. Now what is the second one? I will convert D oil because I know that the oil is not stationary, but the difference of the first difference is stationary. So I'll go to the quick generate series, because this series now required write down D oil. This is my new variable equal to D upon difference of first difference upon oil. So I generate this data now. Now I'm having the D oil now. See, D oil is there. If I check the graph, now see this is now converted into the stationary, but some clustering volatility is there. So I want to see when you do the forecasting. So what is the first step? The first step is please check the stationary through init root. Again, I will explain the new concept. Then let's talk about the second one. So what is the conclusion? D oil is stationary, but oil is not stationary. Then I will go to the next one. File. Now the next page is called gold price. Now if the gold price, click the series statistics, go to init root test, write down gold price, gold price, see whether it's stationary or not. The label, I see there is what is the null hypothesis? Gold price is Init root. It means gold price is non-stationary and the p-value is greater than 0.05, which proved that we cannot accept this, we will reject. So it means gold, sorry, we cannot reject this, we should accept this. So we proved that if the p-value is greater than 0.05, it means the data is non-stationary. So what I will do, I will check, can the first difference of these will be converted to stationary, which I can use. I'll go to the quick, go to the group series statistics, the Init root, write down the what is the price, gold price. Now go to first differences. When I see the first differences, now see the p-value is less than 0.05, which means this null hypothesis is rejected, which shows that the difference of the gold price is Init root is rejected. We can prove that the gold price, difference gold price is stationary. So please remember two things, just write down. If the p-value is greater than 0.05, data is non-stationary. If the p-value is less than 0.05, data is stationary. Those are want to understand like this. And if you're interested to know Init root, if the p-value is less than 0.05, it means null hypothesis is rejected. Rejected means that we have written null hypothesis, D gold price Init root is rejected. It means D gold price has no Init root, that is stationary. Then what I will do, I would convert the series, generate the series. Now instead of the gold price, I will write down G gold price, which I will use for forecasting. Then that is called equal to D of gold under price, bracket close. Simply you say, okay, now see, when is the D gold price, go to the view, go to the graph, go to the graph. Now see, it is sometimes it is converted into the stationary. So the first inferences we concluded that first we have to check the original data. If data is stationary or not, we will check the we will check the Init root test. There is another concept to check the whether data is stationary or not. That is called Coriologram. I will explain now what is Coriologram. Because listen, I don't explain the concept theory. I will explain about, you should know the practical things. Let's go to the, I will click this. Now, let's talk about the original oil. Now, please go to the view. There is called Coriologram. When you see the Coriologram at level, what you see, now see this is called ACA autocorrelation. PAC means partial autocorrelation. Q statistics means link Q test. Now here, what is autocorrelation? It means the correlation between the first leg with second leg is higher, second leg, third leg is also higher. So there is a two different term. Let's see, there is a दो लाइन यहाँ पर होता है, इसको बोलते हैं control limit. अगर control limit से अगर बाहर जा रहा है, तो मतलब है ये data non-stationary है. So what I will do, I have seen that now here the autocorrelation is also go outside of the control limit. Again, the only one spike there is there. So I can say that with the help of what is partial autocorrelation? The partial autocorrelation means we calculate the autocorrelation of 1 and 3 with 2 remain constant. 2 and 4, 3 remain constant. It means you take any correlation between two series, two leg with another remain constant, that is partial autocorrelation. And for the stationary, whether it is the AC or PAC, that should be within between the control limit. Now we concluded that Coriologram of oil is not stationary, but I want to say the second one, that is I have already converted the data into D oil. Can the D oil go to the Coriologram? Now check the level. Now it is see within the control limit. Thoda spike of control. Now we concluded that we can check our data stationary and non-stationary with the two series. One is called Init root test, another is called anybody, what is Chandriya, what is second one?
Coriologram graph.
Coriologram. Now let me talk about the stop. So first thing, we are clear that So we see decoupled test, augmented decoupled test, and Phillips. Similarly, there is another terminology called Phillips Heron. You check the p-value of Phillips Heron. If it is greater than 0.05, it is non-stationary. If it is less than 0.05, it is stationary. Now see, this is called Coriologram of non-stationary. We have already generated. This is the Coriologram of stationary. So, dear participants, first of all, whenever you collect data, don't predict, don't apply directly your model. You check the data is stationary or not. Step number 1, draw the diagram. If it is trending, then you have to check that with which level it is stationary. Then there is a concept called Init root test and Coriologram test. In Init root test, take the level 99% data never be non-stationary because it is a trending data. So you always see, can I convert into its log? Can I convert into fast differences? Can I convert price data into return data? Because I want to transform the original data to find out stationary, and from the stationary data, I can predict, I can apply any model. I hope you remember this. You just see this is control limit. All the spikes, all the correlation within the control limit. It means this is called stationary, or this is called non-stationary. So I will already give this PPT. Those who have जिसको लग रहा है कि समझ आएगा तो आप इस PPT देख के कर सकते हैं. I got the unit root. I apply the ADF test. I go apply label. Then I say okay. Then I will find out this data. If the value is here, now what happened? जो भी मैं आपको analysis किया था, अभी मैं इसको PPT में बता रहा हूँ. The value is here is greater than 0.05. It means data is non-stationary. So what I want, so it means stationary. So what I will do, I will convert into the difference, because difference मेरा नहीं हो रहा था. जब मैं log का data ले लिया, then what happened? This variable is changed. Now the p-value is stationary. Now I have seen the interesting figure I want to share all of you. There are some faculty who use this ADF test, Phillips Heron test, and that submitted one paper for conferences. Do you think that by conversion of stationary, non-stationary to stationary have contributed something? I think no. But I have seen that in many conference paper, they apply the stationary and they publish the paper with the conference. So my dear friends, this is the fundamental step. The fundamental step cannot be a research generalizations or research contribution. So you have to do the fundamental things that check data stationary and non-stationary. Everybody is okay now? Is it okay?
Yes, sir. So
what is the first 10 minutes conclusion in your root test? We have used two things. One, Init root. Second is Coriologram. Init root, we'll go for ADF and Phillips Heron, and we'll see the p-value should be less than 0.05. If it is not there, I will go for the first differences. If again I will not find any less than 0.05, I go for second differences. Within second differences, that is called second leg, the data may convert into stationary. So please remember, my dear participant, this leg में, जिस आपका वेरिएबल में आपका कन्वर्ट स्टेशनरी होगा, वो हमारा मेन डाटा हो जाएगा. ओरिजिनल डाटा को हम रिमूव करेंगे. जो डाटा हमारा स्टेशनरी कन्वर्ट हो गया, इट इज फर्स्ट डिफरेंसेस और सेकंड डिफरेंसेस और लॉग डिफरेंसेस और डिफरेंस ऑफ लॉग, whatever you have converted, it's converted stationary. That will be used for the forecasting, not your original data. This is the first and foremost thing. Please don't use this stationary concept in your published one paper. That is a fundamental step. You will take one paragraph for each and every paper. Now the next is, why does one use time series data? They may be forecasting. There are two things. हम टाइम सीरीज में क्यों करते हैं? हम सपोज देयर इज अ टू थिंग. दिस इज कॉल्ड BSC प्राइस इन BSC इंडेक्स and this is the Reliance index. I want to find out whether both the indexes are co-integrated, or is there an impact of BSC on Reliance, or is there an impact of Reliance to the BSC? So I can go for relation between cause and effect. This is one. For that I can use time series data. Second, I want to predict, this is your data series, I want to predict the next 20 years. Now when I predict this 20 years, so every data, every observation is impacted with this past observation. That is the fundamental concept of time series. हमारा टाइम मार्केटिंग में क्रॉस सेक्शन में ये नहीं पॉसिबल है. इट मींस अगर मैं बोल रहा हूँ, if I am saying that this is 2019, these data, and this is 2018, but this 2018, these data. So it means there may be some impact. It may be information, it may be shocks, it may be volatility, there may be some news, some impact by which it is declining. For example, अभी हमारा चल रहा है कोविड, तो कोविड में जब मार्केट से चल रहा था, मार्केट में डाउन हो रहा है. Now this is some impact. It may be impact of COVID. So you can find out on one research paper how COVID, whether COVID is an impact in the forecasting or not, whether COVID has an impact on correlation or not. So we can use the COVID impact in your forecasting. So what I'm interested to analyze, when you do analyze the forecasting, the two things very important. One is whether data is stationary, you can directly apply forecasting, but there is some problem. Problem is that, I will explain what is the problem. Problem is that here I have converted data into non-stationary. Now I will predict certain future time series. But I have seen there is some clustering volatility. मतलब for example, अभी क्या ऐसे हो रहा है, फिर से यहाँ है, फिर से ऐसे आ रहा है, then again it comes. So this is clustering volatility. So we have to also take into account. So when you go to forecasting, you can directly apply different models. And what are the models? You apply autoregressive model, you apply moving average model, you apply ARIMA model, you apply arch model, you apply Gratz model, you will apply Bhar model, you apply ECM model, or you can apply VCA model. I will explain one by one just within 10 minutes. So you should, before going to the analyze, you should know when you apply autoregressive. Let's talk about autoregressive. What is autoregressive? Autoregressive means the YT is the depends upon YT minus 1. It means अगर आपका आज today's price depends upon the yesterday price. Okay, so how can say that YT depends upon YT minus 1 and YT minus 2. It means what? Today's price not only impact on the past price, but also it's the second leg price or the previous. That is 2019, 20, 19 depends upon 18 price and 17 price. So when you have only one past observation, उसको बोलते हैं AR1, autoregressive one leg. When you have used two things, you can say AR2 or two leg. So like similarly, you have ARP leg. P leg means there are many legs you can be carried out. So it means the autoregressive means if you want to predict the current sales based upon the previous and its past leg, it is called autoregressive. I can predict on that, but sometimes people say that no, I will not. There is some residually clear, very important role. You have predict YT is based upon UT minus 1, the residual of first residual. Then it is called the moving average of 1. When you say moving average, that is the residual impact. Or you can say that YT is based upon UT minus 1 and the second residual T minus 2. We can say moving average 2 legs. It means that today's price not only depends upon the residuals or difference of the informations or the shocks of the previous one, but also its second leg. So you can apply autoregressive, it means own leg, and moving average residual legs. Chandrika, am I audible?
Yes, sir, you are audible.
So now there is a call ARIMA model. ARIMA means I will use both YT and depends upon YT minus 1 and UT minus 1. Means I will take one past observation and one residual information. इसको बोलते हैं AR1 and MA1. So when you, this is, इसको बोलते हैं mean equation, I have to calculate. Now the question is, sir आप पूछोगे सर कितने से निकालेंगे? How you can say that in which AR, whether I can go for 3R or MA, do 3 MA, then I can better prediction. I will explain about, there are different methods to find out how you predict your model through ARIMA. AR means autoregressive, past leg, MA means moving average, the residual legs, and ARIMA means integrated. Integrated means suppose whether both are the stationary at the first level, then I'd say that AR1, okay, I can say that ARIMA 1, 1, 1. What is 1? This is P, this is D, this is Q. P means AR ka leg, D means differences, and Q means moving average leg. I will explain one by one. And sometimes I will use Grach model. What is Grach model? When you have seen that in residual, there is a clustering volatility. Then to remove that clustering volatility and have a better prediction, we will use Arch for mean equation and use Grach for both mean and variance equations. I'll explain one by one. So now these are the very important points. Please remember, when you predict certain things, some other variables are impacted. Time also impacted, own history also impacted, past also impacted, and combination of these can impacted. So if we predict the time series in better way, we will be a millionaire for that particular point of time. Let's talk about ARIMA model. I've already explained about autoregressive process. It is a current value depends upon its own previous value. And moving average means the current deviation from it depends upon previous deviation. And ARIMA means both the things. And ARIMA means integrated. So let me explain about this is called AR. It means it is this value depends upon its past observations. और suppose I want to predict मेरे पास डाटा ये नहीं होगा मुझे predict करना है 21. So 21 को जो predict करूँगा, I can use only 20. I can predict. I can use 20 and 19. That is 2 AR. I can predict. I can use 3. तो मुझे पता जाएगा कि ये जो मॉडल मैं बताऊंगा 21 का, ये मुझे 1 लेग पता लग जाएगा ना 2 लेग, ना 3 लेग, ना 4 लेग, और what should be the autoregressive component I should take so that I can predict better. Sometimes this is called moving average. So if you want to predict some future time, I can also take the past leg or its previous leg like this. So when you integrate these two, we will find out ARIMA model. So now see how we'll write in ARIMA in our research paper. Suppose when say 201, it means two leg. Anybody what is 201? Means 2 own leg and 1 residuals. What is 301? 3 own leg and 1 residual. What I can say that ARIMA 303. What does it mean? Anybody?
3 own leg.
3 own leg and 3 residual. Now what is 0? 0 means we assume that both the series X, the series of X is stationary at 0 level. तो मतलब अगर 0 में लिख रहा हूं मतलब है मेरा डाटा ओरिजिनल लेवल में ही स्टेशनरी है. If I say 1, it means first difference में स्टेशनरी है. If I say that ARIMA 313, what does it mean? 3 own leg, first difference of the data, and because it's stationary, moving average. So when you take all the 3, we'll predict the things. I've already explained about what is PDQ. P means the autoregressive component. D means first differences, where is the level stationary, or it is the first difference stationary, or second difference stationary. Now see how we will apply the model. Now suppose when I say the ARIMA 201, it means here now see 2 component of AR. It means I will take the one past leg and second past leg and 1 residual. Is it clear? Now what is 0? 0 means Y as it is. If I say 110, what is 110? Now here that instead of YT, the first difference is stationary. So I will predict the first difference, which is the depends upon its own stationary. Now data converter. Is it clear? Now we'll talk about the ARIMA model through. Okay, I will explain through the reviews, then I'll come to the PPT, then only you can explain. We'll do the better one. Now go to the this one. Is it visible now? Is it visible now?
Hello? Yes, sir, it is visible.
Now,
visible, sir.
Now we've already converted data into D gold price and D, which one? Return price. Now I want to predict a ARIMA model of D gold price. I want to predict the gold price of next 5 years. Now, can I apply directly gold price? Yes or no? Can I apply directly gold price? Yes or no? No, because the gold price is not stationary. So I have generated series D gold price. Now from the D gold price, I have to go for the stationary. But there is a beautiful model, packages in reviews. You can directly say that you don't require to find out D gold or differences. Please go to the gold price. मैं gold को click कर रहा हूँ. Where is the gold? Gold price. Now there is a call probe. That is called automatic ARIMA forecast. Is it visible now?
Yes, sir.
Please click. So means I want to predict the gold price of next 5 years with the help of ARIMA modeling. I don't know what is the AR component, how many components I have to take of auto own leg. I don't know how many residual legs are taken, and I don't know whether it is in stationary at level or fast difference, second differences. So there is a beautiful e-use package is there. You just write down automatic ARIMA forecasting. Click that. Now see, what is the first one? He will take out maximum दो difference करके वो check कर सकता है कि वो stationary है ना नहीं है, and he will take the random by default. He take the 4 autoregressive or 5 autoregressive. You can increase the autoregressive component, but for time being, I will use 4 and 4. Is it clear? Is it clear? Hello, am I audible?
Yes, sir. Yes, sir. You are audible.
Now then click option. I want forecast comparison, ARIMA graph, and equation output table. Simply, my dear participant, very easy. Again, I'm explaining. Click the gold price. You have it the series now. Go to the quick. Go to the pro. Write down the pro. आप पूछोगे सर इतना सारा पढ़ा रहे हैं because मेरा objective है कि 1.5 घंटा में I will explain the concept reviews. You will be ignite and sensitized. Then one tools you can go for one workshop. That will be better for research writing. But being the first time, you should know what are different component of time series. In Pro, go to the ARIMA forecasting. Now here, I don't require to convert the gold price into D-gold price or return price. I don't want to know. You already मतलब software बता सकता है. मैं क्या कर रहा हूँ? Specification में मैंने देखा 2 difference लिया हूँ, and I will take the 4. What is 4 or AR4 means? Anybody who can explain what is something? What is AR4? Why T minus 1, T minus 2, T minus 3, T minus 4? What is
T minus 4? Yes.
U T minus 1, U T minus 2, U T minus residual first leg, residual second, third, and fourth. Okay. So now I go to the option. I click forecasting, ARIMA equation. When you say the OK, now see the very important point. He says that your gold price is not stationary. You have to convert stationary for better model, calculate log gold price, then find out differences, which is highly stationary, strong stationary. Is it clear? Hello?
Yes, sir. Yes.
Now see, second he says that the
yes, sir.
model, selected model, he said the 0, 0. What is 0, 0? What is 0, 0? It means autoregressive AR 0 and moving average also 0. So 0, 0 में आपका कोई leg जरूरत नहीं है. तो one leg में model आपका better predict हो गया है. So it means you will take, suppose sometimes I will use the second one. Now see, instead of gold price, I want to predict the oil price. What I will do? Go to the probe, go to automatic ARIMA, go to the option. I want forecast. Click OK. Now see, what is anybody? What is the better model? Is said area model. What is the better model?
2-1.
What is 2-1?
2-1.
Auto regression
or 2. Moving average 1.
Moving average 1. Now we got the auto regressive 1 is significant. Auto regressive 2 is also significant. Moving average also significant. So we concluded that we want to predict. Then what is the conclusion? Conclusion that when you predict the oil price, then it depends upon its first leg and second leg, and depends upon its own first residuals. And this sigma square is called the volatility, is also significant or residual. Okay. So if you go to the ARIMA criteria graph, you see the two out of the they have analyzed how many model 1, 2, 3, 4, 5, 6. There are 25 models are there, but the first model is said is very good because 2100 mein Eka information is the best one. Clear? So he established all the model and he said that the 2-1 model is the best model because it says that AIC is the सबसे AIC lowest होना चाहिए. AIC lowest होगा तो model perquesting ज़्यादा होगा, model better होगा. So we concluded that 2-1. Then question is how to predict this equation. Then what I will do? What is my conclusion? What is the conclusion? When you apply ARIMA model, how many AR component I will take? Anybody? How many air component I will take?
2.
2.
2. And how many residue I will take?
1, sir.
1. Then
1.
I will go to the criteria table. I go to the ARIMA criteria graph. You will see the graph also. Then you will see all the graphs. Now question is how to estimate the equation. You can estimate the equation. Go to the quick. There is called estimate equation. Write down gold. Now what is the next one? D log oil. Is it clear? Now it is our stationary. Any doubt
Yes,
after
sir.
this? Any doubt?
No, sir. No, sir.
Equal to constant. Then you write down AR 1 to 2 and MA 1. Is it clear now? Hello, is it clear now?
Yes, sir.
Yes.
Yes, sir.
Yes,
It is
sir.
like a regression model.
Is it a regression model? Now what happened? I have generated this data. Since data is not here, so first you converted log oil, then you converted fast differences, then you apply this model, or directly you have seen the output of this ARIMA model is here. Is it clear? So what? Hello,
Yes, sir. You are audible.
you're audible. Now the inverted AR model also is significant. So I can predict that the ARIMA model, if you want to forecast in the oil, then the oil can be predicted with the help of its 2 own leg and 1 residual.
Moving
and
average. Residual.
also significant. Now I'll go to the PPT. Okay. Let me. Okay. Now the AR is stationary. I've already explained about. Here. And how many models are? What is AR component? How many AR components
3.
are there?
3, sir.
It means when you predict the dependent variable of 6 month prediction of koroge, now we conclude that the prediction can be possible if you go for 3 its own leg.
1 lakh.
and
2 residuals.
You can have a better prediction. Now the question is, मैं यहाँ पर एक problem बताना चाहता हूँ. I will explain because it's a very important point I want to say to all of you. So please go to the now you already go to the there is called view and go to the Coriologram that is called forecast evaluation. So when you go, you all calculate the evaluation, sample mean, trend mean, everything can be calculated. And if you go to the Init root test, you also find out now your first difference is now significant. It means the model is significant. Now come to the next one. Okay. Now, if the AR and MA inverted root is less than 0.05, you can say that there is no init root. It means that the model is significant and variable is stationary. So let's talk about Granger causality. What is the first one? Anybody? What is the first one you discussed? First, we discuss about time series.
Stationary.
Converted into stationary through 2-way. One is Coriologram. Second is Init root.
Unit root.
You use ADF test or Phillips pattern. Then you calculate that which data series is stationary. Second, I explained the forecasting through first generic model is called ARIMA model, that is enumerate model, where AR is called autoregressive component, that is its own leg. Clear? Then moving average is residual, and I take the combination of both that ARIMA model and to find out. So, but if you apply the ARIMA model in your research paper, it will also be preliminary in my point of view, because ARIMA model is a very enumerate model. Here you can find out you can predict only single variable. Okay, so suppose you have 5 variables, then you have to do ARIMA for each and every variable and calculate the equation. Now the next part is I will find out Granger causality. What is Granger causality? Sometimes I want to know when are the 2 variables. 2 variable means now come to the 2 variable or more than 2 variable. X1, suppose GDP, inflation, and money supply and interest rate. I want to know whether GDP is impacted inflation or inflation impacted GDP. GDP causes inflation or inflation causes GDP, or GDP causes money supply or money supply causes GDP, or inflation causes money supply. It means I want to find out interrelation, cause and effect among the variable. then there is a beautiful model we are having called Granger causality model. Is it clear? Hello, am I audible?
Yes, sir. You are audible.
Yes, sir.
In cause means why, effect means what. So a variable x would be causal to variable y if x could be interpreted as the cause of y or y as the effect of x. You can write in both ways, whether x causes y or y is the effect of x. Is it clear? Now, this concept is developed by Professor Granger, and he explained that when you say Granger causality, then cause always be preceded effects. This is a very important, powerful point. There are a lot of good paper published in a very good journal in Granger causality. What is the first duty? First, to collect all the variables. Suppose I want to predict a macroeconomic variable. मेरे पास macroeconomic variable मैंने 7-8 variable लिया, and I want to find out the relationship among them. After that, I'll go for the model predict forecasting. Now let's see. ARIMA model हमने relationship नहीं देखा. हमने देखा कि how to better predict based upon its own information, past information, and its own residual information, deviation information. But in case of Granger causality, you apply the forecasting through Granger causality. First, it helps you to understand whether there is a relationship exists or not. If yes, if it is y is related to x or x is related to y. Is it clear? So now the difference is that in generally common language, we say that y causes x. Y, but in case of econometrics, Granger causality, we say that x Granger causes of y. Don't write in your research paper x causes y. You always use Granger causes. I will explain why. It means if x t, what is xt? Is it dynamic or continuous time series? Anybody? I've already explained the first one. There is x bracketed t and x is.
I think dynamic, sir.
Dynamic. It is not continuous. Continuous means x bracketed t over.
Bracket.
Right?
Yes.
So xt improves the forecasting performance of yt. Then we can say that xt Granger's causes y. Now see. Now you can write your paper with the impact of macro variable performance for forecasting of GDP. Then what happens? You calculate. You just find out all the information which impact on GDP. Then you apply Granger causality model. Find out which is the causes, which is the effect. Then you apply the model called VAR. So jointly you can apply Granger causality model and VAR. I'm going to explain about the second concept here. Similarly, if xt does not improve the forecasting of yt, what I will write? We will write xt does not Granger causes yt. So now another thing is that in time series, always your present thing depends upon the past observations. It means when you say the past value of x, I'll explain y, then you can say that x causes y. समझ आ रहा है? अगर x का past value t-1, t-2, t-3, if it help to predict y, you can say that xt series is Granger causes y. So if xt series Granger causes to y, then I will use xt as an independent variable for y for my model. Is it clear? But till now, I don't know whether GDP is impact inflation or inflation impact GDP. So first, to understand the impact and causes, effect and causes, I would apply Granger causality model. So this is very easy. I don't want to explain about the mathematical part because there are a lot of participants are here. I'm happy to see. But if I use the mathematical terminology, then many of the participants will be left out. But I'm explaining about how to use the Granger causality effectively through e-views. So now I will explain. I will go to the file. Whenever you open any file, go to the file, open foreign data file. You always use foreign data file. Okay. Whenever you open any file, डायरेक्टली आप फाइल ओपन नहीं हो सकता है. आपको क्या करना है? फाइल जाना है, ओपन क्लिक करना है, फॉरेन डाटा फाइल ओपन करना है. तो मेरा पास मैंने कुछ मॉडल यहाँ पर वेरिएबल रखा हूँ, दैट इज कॉल्ड लेट अबाउट impact of Indian economy. Is it visible now?
Yes, sir.
Now see, what are the variables here? GDP, interest, money supply, and wholesale price index. What is my objective? What is my problem? Problem is, I want to know whether GDP causes interest or interest causes GDP. Whether GDP causes money supply, you can write a paper on this if you have complete information. Whether GDP impact interest or interest impact GDP. The GDP impact money supply or money supply impact GDP. So what I will do, I will simply click all these variables: GDP, interest, money supply, and wholesale price index. Is it clear?
Yes, sir.
Go to the quick. There is called group statistics and Granger causality. कुछ भी नहीं करना है. Select a variable. Go to the quick. Go to the group statistics. Simply click Granger causality test. Now all the जो भी मैंने select किया हूँ यहाँ पर information आ गया. GDP, interest, money supply, double pay. You can take more than 10 variable, 15 variable at one time. If you want to write a good paper, then first thing is that you have to find out all the variable which is related macroeconomic variable. You collect all the information. You can apply. Suppose those are interested to work on stock market, derivative market, or insurance market. You also find out all the information about the stock market. You apply Granger causality model. I will share some of the file to Chandrika and he will share to all of you. So what you will do, simply click, again मैं बता रहा हूँ, simply बता रहा हूँ, click GDP, all the information, GDP, interest, money supply and WPI. Go to the quick, go to the estimate group statistics. This is called Granger causality test. Now see GDP, interest, all are coming under. Now here I will go see, first what I do, मैं ये 2 लेख ले रहा हूँ. मतलब मैं सोच रहा हूँ कि 2 लेख में मैं चेक करूंगा कि इनका रिलेशन है ना नहीं है. Then I'll go for more leg. Then I find out what is the better leg. Go to the OK. Now see the first one. Is it visible now?
Yes, sir.
What is the first one? Interest does not Granger causes GDP. And second one is null hypothesis. What is alternate? GDP does not Granger causes interest. Now see, if the p-value less than 0.05, please repeat me around. If the p-value is less than 0.05, it means the null hypothesis will be rejected. But if the p-value is greater than 0.05, it means null hypothesis will be accepted. Now here, interest does not Granger causes GDP. What is the p-value? Anybody?
0.72.
0.72 is higher than 0.05?
Yes, sir.
It means I cannot reject this.
No, sir.
So I can say that interest does not causes GDP. Clear?
Yes.
First conclusion. Second, if GDP does not causes interest, what is the value?
0.07.
It means what?
0.05
से ज़्यादा हो गया?
Yes,
Again,
sir. Null hypothesis.
So GDP also not impact. So what is the conclusion? Neither interest nor GDP impact each other, Granger causes to each other. Is it clear? Now please see.
Yes,
Is
sir.
there any variable which is less than 0.05? Yes or no?
Yes, sir.
Is there any variable which is less than
Yes.
0.05? Perhaps not.
M1
Yes, sir. Money supply. Money supply doesn't
money supply.
rank
So
across
now what is the
interest.
general conclusion? General conclusion that if you take only 2 leg, it means information of the first and second, we concluded that money supply, because this p-value is less than 0.05, it means this null hypothesis rejected. So what is conclusion? Money supply Granger causes interest. It means अगर money supply ज़्यादा होगा, interest rate को impact कर रहा है. Out of all the macro variable, only one variable is significantly related. That is money supply Granger causes interest. Clear?
Interest.
But
Yes, sir.
the question is, then I will go to analyze to 4 leg. मैं चाहता हूं कि इंफॉर्मेशन 2 इंफॉर्मेशन में तो कॉज नहीं ऊपर है, मैं 2 और 4 लेग लेके देख रहा हूं कि अगर मैं इसका इंफॉर्मेशन इंटरेस्ट का 4 लेग में कुछ इंपैक्ट होगा क्या. व्हाट हैपन? आई गो टू द क्विक, go to the group statistics, then go to the Granger causality, click OK. Now instead of 2, I will go for 5. Let's take out the 5. When you say yes, now see what happened. It is only money supply.
Yes, sir. Money supply.
Nothing else.
Yes.
Then I want to check to go for next group statistics. because 2 में नहीं हो रहा है, 6 तक भी नहीं हो रहा है. I go for the next is, let be, don't go by more, let be 8. Now see, nothing. कोई भी नहीं हो रहा है, ज्यादा ये भी significant नहीं है.
Except money supply.
Except money supply. So what is the conclusion? Out of all the macroeconomic variable, it is only money supply which causes interest. Is it clear?
Yes, sir. I think in 8 lakhs, money supply doesn't Granger cause. The
0.
p value
ज्यादा हो गया तो इट मींस सबसे ट्राई क्या करोगे तो देयर इज अ मेथड कॉल हाउ टू चेक द लेग वैल्यू ओके हाउ टू चेक द leg value.
lag
I
value.
will explain with the two concepts. One is called bhar, then मैं आऊंगा bhar and Granger का जिसका leg. So what is the conclusion now? Up to 5 leg, we concluded that money supply Granger causes interest. I hope when you take more than 25 variables at a particular point of time, then you can write a beautiful paper which causes and which is the effect. You clear now?
Yes, sir.
You clear?
Yes.
Now there is a concept called आप पूछोगे sir how to check the leg. Now after bhar I can explain how to check the leg. Now go to the so any doubt regarding Granger causes?
No,
Any
sir.
doubt? Hello, I'm audible?
No, sir. Yes, sir. You are audible. No doubt, sir.
Is it visible?
Yes, sir.
Which one? PPT or the e-views?
E-views.
Now let me check our PPT. Now come to the next one. What is the next one?
Why?
But what is Granger causality? What is the objective of Granger causality? In Granger causality, what if, listen, 90% of research paper, those who are interested to write in econometrics, what they did, they collect the information and you see the very good paper for Granger causality. But for that, you require a data set, number one. Now, मैं यहाँ पर एक problem किया हूँ. Anybody who can find out what is the problem? I hope anybody who can say that what is the problem? I already told that directly you cannot apply modeling. First you check the stationary. But now in my case, do you think that GDP and the money supply is stationary at level? May not be. So what is the fundamental rule? So I did a wrong thing there. First I checked the stationary at which level. After converted the series, then apply Granger causality. Is it clear?
Yes, sir.
Is it clear or not?
Yes, sir. It's clear.
Now, suppose, let me explain about the, hello?
Sir, you are audible.
Audible, okay. Now see, is it visible now? This e-views file, go to the gold price and now this one. Finish. Now see gold price and oil price. I want to check the Granger causality. What I did, I have calculated return price of gold and return price of oil. Is it visible now?
Yes, sir. This is
so
visible.
You know how to calculate return. I don't want to spend more time on return gold and return oil. So what I interested, I want to check the Granger causality of gold and oil. So what I will do, anybody? Just click both the things because this is stationary. The return price always be stationary. You clear or not?
Sir.
I converted the gold price into return gold and oil price into return oil. Go to the quick group statistics, Granger causality, return gold and return oil. Click OK. Leg 2. OK. Anybody? What is the conclusion? Do you think the return oil, Granger causes return gold? Yes or no?
No, sir.
No. Do you think the return gold causes return oil? Yes or no?
No, sir. No, sir.
So both are independent. So if I want to go for the highest leg, suppose I will take the leg number 8 just to check the model, whether it's good or bad. I will take the 6. Now see again 6 also, don't go for higher leg because the question is why I'm not advising you to take more leg, because अगर आपका prediction अगर 2 or 3 leg में नहीं हो रहा है, you take 8 or 9 legs, then there will be some error because there is a volatility among the data. So you always take the 3 or 4. Now see up to 8 also we predict that there is not Granger causes. So it means we conclude that return oil and return gold are independent each other. Is it clear now?
Yes.
Okay. Now come to the next one. Scale price. Now come to the next one. Is it visible?
Sir, screen is visible. Yep.
Okay. Now come to the VAR. What is the VAR? VAR means vector auto regression. Now see, here we'll find out relation between the price and its own leg. पहले हमने क्या किया? Variable के अंदर relation ढूंढा था, है ना नहीं? Hello.
Yes, sir.
Now अभी हम क्या करेंगे?
Sir.
अभी हम क्या करेंगे? Now we'll find out the relation between the y1 with y1 t minus 1, y1 and yt minus 2, and y1 and like this. So it means we have to calculate whether the current price it depends upon its own leg, cause or not, or current price causes its second leg or not. Similarly, you have to calculate all the VAR model. So this is called the VAR model, where we have to take the y1 is the t1 minus 1, t2 minus 1, y2 depends upon what is y11. Anybody? What is first one? First variable, first timing. Second
Price.
variable, second timing.
First time.
What is GDP? This is inflation. Am I right or not? This is GDP. This is GDP. This is inflation. Clear? So I want to know GDP का impact, GDP का one leg and inflation का one leg में impact कर रहे हैं. तो inflation का impact GDP का one leg और anybody? Inflation and GDP
का second leg.
So now when you have a multiple relationship, this dependent, we are having this model. So we can say that I want to find out Granger causality test of two variable system. This is called the system equation. Which equation?
System equation.
Now, how many legs have taken here? Anybody? How many legs have taken?
1.
2 legs. Now this is leg 1, leg 2. Clear? First variable, the second variable, and second variable. Is it clear?
Second variable. Yes.
तो फर्स्ट वेरिएबल का जो रिलेशन डेवलप किया हूं मैंने. नाउ सी बोलो सर इसका एप्लीकेशन बताइए. नाउ मैं बता रहा हूं जीडीपी ओके ऑफ 2021 इज इक्वल टू अल्फा 1 कांस्टेंट टर्म अल्फा 1 जीडीपी ऑफ t minus 1 plus GDP t minus 2 plus inflation t minus 1 plus inflation t minus. So what is my objective? I want to know whether the GDP of present depends upon its own leg, first leg depends upon second leg, or its inflation first leg or inflation second leg. Means which is the Granger causality. Is it clear now?
Yes.
Now for that, let's talk about the same concept, macro variable. I will use macro variable. Go to the file, open foreign data file. What is my foreign data file? That foreign data file, Indian economy variable. I will take this variable, time series, Indian economy variable. Next, finish. Is it visible now? Is it visible now? Hello?
Sir.
Which one? EViews or PPT?
I think PPT is visible till now.
Okay, very good. Now go to the.
It will come, sir. EViews will come, I think.
Now it's visible now? Hello?
Sir, this is visible. EViews now visible.
Now what happened? We have seen that in this case, Granger causality, we only concluded that money supply causes which one? Interest rate.
Interest.
Now I want to know, go to the option quick, go to the estimate VAR. Which one?
Estimate VAR.
Now this is called standardized VAR. You just click, what is the dependent variable? What is my first dependent variable? GDP. What is my second one? Interest. What is third one?
Money supply.
What is the fourth one?
Wholesale price index.
Wholesale price index. Clear?
Sir.
Now see, what is the lag interval I have taken?
2.
Till now, I don't know which is the better leg. What is the maximum leg? So I can find out what is the better leg. Now simply मैंने क्या किया? कुछ भी नहीं किया मेरे भाई. Participants. I have selected all the variables. I apply the VAR and I have to select 1 and 2 leg. Up to 2 leg I have to check. Now इसका मॉडल कैसे बनेगा बताओ? GDP is equal to alpha 0 plus GDP leg 1 minus 1, GDP 1 minus 2, interest 1 minus 1, interest 1 minus 2, money supply 1 minus 1, money supply 1 minus 2, double by 1 minus 1, double by 1 minus 2. Clear?
Yes.
Simply click OK. Nothing, do anything. Now, anybody? GDP is a dependent variable. Clear? Now see the very two important one. This bracketed value is called standard error and this parenthesis is called t value. So first you check t value should be greater than equal to 2. क्या होना चाहिए? दो t value कितना होना चाहिए? If t value is greater than equal to 2, then that is significant. The relation is significant. Now here what happened? GDP and its own leg significant. Am I right or not?
Yes, sir.
How will you predict? GDP is Granger causes of its own first leg. Clear?
Sir.
But not in second leg. मतलब जब प्रेडिक्ट करेंगे, हम जो प्रेडिक्ट करेंगे जीडीपी का जो हम मॉडल में वेरिएबल्स यूज करेंगे, आई विल यूज वन जीडीपी 1 - 1. I will never use GDP -2. Clear? Just write down, when I predict GDP, I will use only GDP -1. I will never use GDP -2 because the t value is less than 2. Can I take interest? Can I take interest?
No, sir.
Can I take interest second leg?
No, sir.
Can I take money supply?
No, sir.
So what is the conclusion?
Only GDP is significant in its first leg only.
मतलब है हमने ये देखा कि due to the Granger causality, I have seen that when you apply the prediction of GDP, I will use only GDP its own leg because GDP does not Granger causes to any other factors. Now, if you take interest, if you as a dependent variable, tell me which is the predict. If interest predict करना है तो किसको लूंगा मैं? Interest its own leg, interest the second leg. Clear?
Sir.
And if you are taking the money supply, what I will take? Interest is money supply का interest one leg. Money supply its own first leg. Clear?
Sir.
And if you will take the WPI as a dependent variable, what I will take? GDP second leg and money supply second leg.
WPI.
Okay. Now I want to check which is the better leg, because till now I am confused. What should be my better leg? Then go to the view. There is called leg structure. Have you seen the leg structure? Hello?
Sir.
Then click.
Sir, it is visible.
Leg length criteria. Okay, just you यहाँ 6 तक हम चेक करेंगे, 6 चेक करेंगे. So I will use 6 as the maximum. Now see in which leg it is minimum. AIC is minimum. Which leg is minimum?
6 legs.
6 legs. So now in all the information, AIC, squads, HQ, all are lower in case 6. So we concluded that instead of 2 leg in bar model, we will use for forecasting how many legs?
6 legs.
So go to the quick, go to the estimate bar. Again, write down GDP. Clear?
Sir.
Second,
interest.
Write down interest. Clear?
Money supply.
Then money supply. What is third one?
Wholesale price index.
WPI. Now instead of 1 to 2, I will write 1 to 3, 4, 5, and 6. Yes. When I see OK, now I am going to the final result. Anybody who can explain? When you predict the GDP equation, which variable you take into account?
Even.
Which one? GDP -3, third leg. GDP
third leg. Fifth leg.
And interest, third leg. And interest, fifth leg. And interest, sixth leg. So money supply, second leg. Money supply, fourth leg. Money supply, fifth leg, sixth leg. Now see, so what you predict, when you take 2 leg, the model is not significant. So when you take all the 6 leg as per the VAR criteria, we concluded that if now what to estimate the equation, I will use for forecasting which variable? GDP. Anybody? GDP minus
third leg.
Third leg. GDP fifth
leg.
So you can cause that GDP is Granger causes of its third leg, fifth leg, and
interest.
Interest third leg, interest fifth leg,
fifth
leg, and like this. Is it clear?
Yeah.
Similarly, if you want to predict interest, anybody? What is the equation I have to use for the estimation?
GDP first leg.
First leg. Then, so it means interest is Granger causes of GDP's first leg. Now you know how to interpret.
Sir.
Then you go to the estimate like this, or you go to the forecast also. You can find out the forecasting method, dynamic or static. So basically, you want to estimate. So is it clear now? There are इसका आगे भी method है how to calculate system equation, but I don't want to give a system equation. But up to this, you can write a one paper that which causes which factor. Is it clear?
Yes.
Now go to the stop share screen PPT. What next? Next is now come to the which model? Last one.
ARC. Dark model.
This is बोलते हैं auto regressive conditional heterogeneity model. It means sometimes when you estimate our forecasting, some volatility will be there, and maximum people who are working in the stock market, they use this Arch and Grach model. There are many family of Arch and Grach, Arch, Grach, M Grach, E Grach, T Grach. There are many family, but basically, generally we are using the Arch and Grach is the basic one. What is Arch? Auto regressive conditional heterogeneity. What does it mean? It means when you estimate some equation and you find some residuals have volatility called clustering volatility. So if the residuals have clustering volatility, then that volatility should be removed. Or another one, number one. Number two, some information, internal information also impact volatility, and some external information also impact volatility. So I want to check three things: whether there is a heterogeneity among my model, yes or no. Second, whether there is a risk in my model, risk in present or not. Third, whether internal information impact my volatility or whether external information impact my volatility. So whatever I will do for that case, generally you're using Arch model, that is auto-regressive conditional heterogeneity model. What is auto-regressive? It indicates that heterogeneity observed over different time period may be autocorrelated or it may be conditional autocorrelated. Now this Professor Robert Engel, he developed this concept that is called Arch model, and he got the Nobel Prize. Simply, there are different arcs, what is called arch, arch M, Grach, Grach M. M is mean value, T Grach, E Grach. So, what the objective of this model is to check the volatility. And now see simple three things. Those who are joined now, तीन चीज हम लोग करते हैं कि रिस्क है क्या, नंबर वन. देन आर्च इफेक्ट है क्या, मतलब हेटेरोजेनिटी नहीं होना चाहिए मॉडल में, रिस्क है क्या चेक करेंगे. देन इंटरनल information means Arch है क्या, and external information that is called Grach impact model में है क्या. मतलब है हम जो forecasting करेंगे कुछ information, for example like this, suppose now see यहाँ पर जो residual का clustering आ गया, residual का clustering आ गया, this clustering is called volatility. This volatility changes. This is because of either there is some internal information, there is a news, or there is a shocks. I hope you know this concept, those who are doing stock market, but I will explain with a very good example. Now, what is the first thing you check? What is the first step of any modeling? What is the first step?
Stationarity test.
Stationarity. Okay. Now I will check the stationarity. This concept you can use for investment planning. I can use in the foreign trade. I can also use in the capital market to understand suppose I want to understand the impact of news in the stock market, or impact of COVID during the investment behavior, or investment behavior and its impulse behavior during COVID period. If this is your objective, then you can apply Arch effect and Grach effect for your model. So simply now see here, what is the model says that? The model says that your YT, what is YT? Anybody? What is YT? Suppose GDP.
Dependent.
GDP or stock price. This is the price of Reliance. Reliance का stock price है. It depends upon its residual. Now see, अभी हमारा काम आ गया खेल. पहले हम क्या कर रहे थे? ऑटो रिग्रेसिव में क्या कर रहे थे? ऑटो रिग्रेसिव we go for own leg. Moving average में we go for residual leg. Granger causality में we go for X and Y relationship. बाहर में what you see? Relation between X and its own leg, and Y in its own leg. Now, there is another model is called, don't take this all the variable, just पूरा खेल हमारा रेसिडुअल का ऊपर होगा. अगर आपका Y depends करता है रेसिडुअल, okay, means then only you can apply Arch model. I will explain this is the model that is called YT depends upon UC plus U2. This is a mean equation. You can after ARIMA also you can check whether Arch effect है ना नहीं है. ARIMA apply करने के बाद भी हम check कर सकते हैं कि heterogeneity effect है ना नहीं है. The ARIMA is a mean equation. I can apply the mean equation. Then another thing that the residual should be identically distributed, normally distributed. That is mean zero and standard deviation should be constant. So let me explain about the model. I don't want to this. Let me explain about this one. Now see, this is Arch one. What is Arch one? Anybody will explain what is Arch one? Arch effect means your dependent variable depends upon its first residue. This is called square of t minus 1. This is arch effect. Clear? What is arch 2? 2. First t minus 1 square, t minus second leg square. What is arch 3? Anybody? What is arch 3? What is arch 3? B0 plus B1 first residual square, first information, plus B2 second information square, plus B3 third information square.
Add information square.
So it means when say arch Q, it's nothing but first t minus 1 square, t minus 2 square, t minus 3 square, and t minus q square. I can write down. So first of all, I want to check in my model, there should not be any volatility clustering. I want to remove the volatility clustering in my model. So I don't want to spend much more time on this. So now see, this is called volatility. I have estimated my model. मैं मॉडल एस्टिमेट करने के बाद मैं देख रहा हूं कि मेरा जो रेजिडुअल आ रहा है, रेजिडुअल में कुछ क्लस्टरिंग आ रहा है. नाउ सी दिस इज क्लस्टरिंग और क्लस्टरिंग रहेगा, then the impact of forecastness will be lower. So I want to remove these forecasting and variance by applying which model? Arch model or Garch model. Now I'll explain about the Arch and Garch model with the help of some example. I don't spend because I have some time. Now see, in Arch model we are having mean equation. In Garch model we are having both equation, mean equation and variance equation. In variance equation we will use the residual autocorrelation, and mean equation we will use only the residuals and do not have an autocorrelation. Now this is Arch model. Yt depends upon b of xt, and please listen. Arch effect may we're not focusing upon this xt or focusing upon the residual. It means residual में कोई clustering नहीं होना चाहिए. अगर clustering नहीं होगा, तो that forecasting is the better forecasting for your model. So let's explain about one concept. Let's go to the e-views. Now suppose go to the file, go to the foreign data file, and I want to know that, okay, let me explain about that file. Okay. Is it visible now?
Yes.
Now, is it visible?
Sir.
Okay. Now what happened? I have दो मॉडल बनाऊंगा आज के लिए, एक सिंपल मॉडल, एक कॉम्प्लेक्स मॉडल. Now here I want what the theory says that the gold price depends upon the oil price. What is my objective? Anybody?
Gold price is dependent on the oil price.
One professor says that the gold price of the market depends on the oil price, and I want to forecast of the gold price based upon the information I'm having oil price. Is it clear? Clear? Yeah. So what I will do, I will simply take the quick, very important estimate equation. मैं क्या करूँगा? लिखूँगा gold price constant. Then which one?
Oil price.
Oil price.
Oil.
Simple model लिया मैंने. मैं check कर रहा हूँ gold price. It depends upon oil. Sorry, गलत किया मैंने. What is the one?
Oil
price. I use the least square method. I'm not using arch model. Simply, I want to predict that whether gold price depends upon oil price. I say click OK. Now I got what is the objective? Yes, I have seen oil price in impact. Yes or no?
Yes.
If oil price increase 12 rupees, then automatically the total gold price will increase 16,614 plus 12 times of the oil price. Clear? Now I want to see whether in this model what is my residual. What is my residual? Means I want to check whether this model में clustering, ये तो अपना model बन गया, whether clustering effect है और नहीं है. What is the first one? Right? What is the first step? Step one is find out your equation. Is it clear?
Sir.
Okay. मैं दो तीन चीजें मैं बताऊंगा. I will take the general, then complex and ARIMA लेके बताऊंगा. I will explain the gold price. It depends upon the oil price, which is significant. Now, I have seen that oil is a significant impact on the gold price, which is predictable also. But I want to see whether it's a good model or not. Then I will check the view. Then I check the residual. See the residual. मैं रेसिड्यूल में क्लिक किया. Now see, fitted, actual and fitted. This is this green orange color is the actual. This is fitted. Now see, there is some clustering. मुझे लग रहा है कुछ clustering है ना नहीं है? तो मुझे चेक करना है कि रेसिड्यूल में कोई आर्च इफेक्ट है क्या. What is the first step? Is there any arch effect on the
रेसिडुअल?
अगर आर्च इफेक्ट है, अगर कंडीशनल वोलेटिलिटी है, देन सपोज यहाँ पर लग रहा है कि यहाँ पर भी एक आ रहा है, तो यहाँ पर भी एक आ रहा है, तो मुझे क्या करना है, चेक करना है. गो टू द व्यू, गो टू द रेसिडुअल डायग्नोस्टिक. देयर इज कॉल्ड हेटेरोसिटी टेस्ट. जस्ट राइट डाउन. इसका रिकॉर्डिंग भी होता होगा ना? हेलो
सर.
ओके. हेटेरोसिटी टेस्ट. क्लिक द हेटेरोसिटी टेस्ट. देयर इज कॉल्ड आर्च. यहाँ आर्च लिखा गया, तो आर्च किया मैंने. आई सी नंबर ऑफ लेग 1. आई से ओके. व्हाट इज माय मॉडल? हेटेरोसिटी आर्च. नॉल हाइपोथेसिस क्या लगा मैंने? आर्च इफेक्ट है. इट इज सिग्निफिकेंट, मतलब है मेरा मॉडल में आर्च इफेक्ट शो कर रहा है. इज इट क्लियर? We write down after estimating your equation, go to the view, go to the residual diagnostic, apply heterogeneity test, check arch effect. If the p-value of arch effect is less than 0.05, it means the model cannot be used directly through least square estimator. We have to apply arch model. Clear? I cannot use simply least square method, because if I use this square method in residual, I found there is arch effect. There is a heterogeneity impact kar raha hai. So to remove that, what I will do, go to the quick, go to the equation, then write down which one, which price. मैं क्या ले रहा हूँ? Gold price ना?
Sir.
Gold price depends upon C and oil. And instead of least square method, I will apply, there is a called arch model. Arch देखा गया ना यहाँ पर? Arch. Now see, when you say arch model, if there is a called arch 1, grach 1. Arch 1 means there will be one leg, okay, one arch effect. Arch 2 मतलब है 2. I hope I already explained 1, 2, 3. 1 means t minus 1. 2 means t minus 1, t minus 2. 3
Second
means
leg.
so there, suppose here I want to apply only arch. I don't apply the grach effect. So zero. I simply say 0. Is it clear?
Sir.
Clear? एक दोबारा बता रहा हूँ. मैं देख रहा हूँ कि आर्च इफेक्ट है, तो इंस्टेड ऑफ डायरेक्ट इक्वेशन आई हैव टू अप्लाई द आर्च इफेक्ट. तो हाउ टू डू दैट? गो टू द क्विक, गो टू द एस्टिमेट इक्वेशन, राइट डाउन योर जीडीपी, सॉरी, गोल्ड प्राइस, then constant, then your oil price. Then instead of least square method, since I have seen that this method having a heterogeneity effect in the residual, I have to go for the arch model, arch autoregressive conditional heterogeneity. And now see, there is called arch and grach. But here, first I will go for arch model. So I put grach is equal to 0. If you want to grach effect, then write down arch 1, grach 1. So now here I'm saying arch effect. Say okay. Now see, oil is significant, yes or no? Hello?
Yeah.
Now see, in case of this is called residual 1 square, this is called arch effect. Arch effect is also significant. मतलब है मॉडल में arch effect impact भी हमने significant हो गया. अभी मॉडल में arch effect नहीं है. Whatever this value is come, that will be better predictable. Now बोलोगे सर कैसे पता लगा आपको? The residual 1 square is called volatility. Volatility is also significant. It means there is no volatility at this point of time. Now, if you want to check further that there is no volatility, it's also about the information, internal information. There is no internal information in now in your, there is no shocks also. You can use the no shock, no volatility, no information. Then if you want to check further, go to the view, again, go to the residual arch effect. Now see arch. Now see, now there is a p value is greater than 0.05. It means in whatever model we estimated now, there is no arch effect. So the model which is estimated, the arch model, is a better prediction in case of least square estimator. Now, instead of that, I want to apply the grach model also. Means to go for external information, simply go to estimate equation. This last one. This is right on the gold price. Then C, then oil. Then go to the arch model. Now, instead of arch 1, write down grach 1. This is called mean equation. If any other various regressors also, अगर आपको external information कुछ होगा, inflation or WPI, whatever maybe information you want to check the external information you can put here and you check that it's variance equation. But now at present I don't have any data. I want to check the gold price and impact on the oil with the help of arch and Grach effect. I say arch 1, Grach 1. I when say the 1. So what I would see that the Grach effect nahi hai, but arch effect hai. Clear? Is it clear now? So there is variance external influence यहाँ model में नहीं है, but internal volatility था वो control हो गया. Now this is the better model. Now you want to check whether the arch model will be present or not. Then go to the view, go to residual diagnostic, click arch LM test, arch. Now see there is no arch effect. Now the probability of value is greater than 0.05. So we concluded that whenever you take the arch model, that is the better prediction by taking residual heterogeneity into your model. Now I will go to the slide. Is it visible now?
Yes, sir.
Hello?
Sir. Sir, your screen is visible.
Visible?
Yes, sir.
Now see, this is arch 1 model. One model means only one information is taken. And this is called the variance, that is the Grach effect. Grach ka always dhyan se dekho, alpha plus this omega always be there. With the arch or Grach, this constant should be there. But our objective is we'll take this mean equation, this is variance equation. And if you want to Grach model, this Grach model developed by two professors, Tim Boltzmann and Stephen Taylor. To understand, we already explained the mean equation. This is called variance equation. Variance equation means external information, external shock is present or not, and mean equation means the impact of internal information, arch effect, yes or no. Please remember the arch coefficient plus beta coefficient should be always less than or equal to 1. It means what is the percentage of risk in your model, what is the percentage of volatility in the model, that can be checked with the summation of alpha plus beta. So thank you very much. I don't go for more on the Grach and error correction. I hope, is it okay?
Yes.
So now the last part I will explain. Just wait. I don't want to explain the co-integration because it is too both ho jayega. So मैंने अभी तक what is the conclusion I am explaining? Let me explain that my concluding part. First is your data. Check the graph. If the graph is non-linear or it is non-stationary, convert into check the stationary through the two tests. What are two tests? Please participate. One is Init root. One is Coriologram. We have ADF test and Phillips Perron. Then once you know this which series, whether label is stationary or first difference or second difference stationary. The next step is generate the series. Generate the series based upon the stationary. Then you apply auto-regressive model, which is based upon yt is equal to yt minus 1, and moving average model, which is called yt is equal to residual t minus 1. Okay. Then you combine between AR and MA with
ARIMA
method. PDQ means how many auto-regressive component, which is stationary, at what level is stationary, what is moving average method. Based upon the significant value, forecast your equation. Number 1. Number 2, I want to find out the cause and effect relationship among my variable. Then what is the best model I have to use? Granger causality. You take all these variable x1 to xn or x10, whatever may be. Then you check the stationary, and according to the stationary, you convert the series of each and every series. Then apply the Granger causality to check that which is the causes and which is the effect. Clear? Sir. Based upon the p-value, if p-value is less than 0.05, it means it is a causes. If p is greater than 0.05, it does not run the causes. Clear? Then if you are interested to know about the variable, interested to predict your equation based upon the VAR. What is the objective of the VAR? VAR means your forecasting depends upon not only its time lag, okay, but also the time lag of other variable. Clear? Clear? So we have to predict the yt, whether yt minus 1 is Granger causes or t minus 2 is Granger causes or xt minus 1 is Granger causes, or xt minus 2 is Granger causes. Based upon the significant, whatever the significant coefficient I will get, I will use that in my question for forecasting. Is it clear? And third, whenever you use the least square method, if you found that your residual having heterogeneity effect or arch effect, then to remove the arch effect, we are having to re-estimate our model through arch model. Arch model says that your yt depends upon the residual of yt, and if it is अगर white arch 1 होगा तो एक ही जाएगा, अगर 2 होगा तो yt minus 1 t minus 2 जाएगा, 3 होगा तो t. These are called in shocks. So I want to predict whether the forecasting depends upon its own shock or the past shock. If you use the mean equation, it is arch. If you take both mean and variance, it will call variance. It is called Grach. In arch model, we check the risk, we check the arch volatility present or not. In Grach effect, we will say that with the external information impact on your stock market prediction or not. Based on that, we will use forecasting. Thank you very much. There are another 3 methods are there: ECM model, error correction, co-integration, and VACM. So this will be, after these 3, it will finish about time series data. Then next is called panel data. The professor will explain about the panel data fixed effect, random effect, and dynamic effect. Thank you very much. Am I audible?
Yes, sir. Thank you, sir, for your insight.
So actually, wait. मैं देखना जानना चाहता हूँ कि मेरा वीडियो बंद हुआ ना? Okay. Thank you very much. Any doubt?
Thank you, sir.
If any question, you can ask me. Now I will try my best to explain. Listen, just I'll take 5 minutes. Now listen.
Okay,
time series, we are having हमारा 7 model होता है. First is stationary. Second is go to the ARIMA. Third one is go to Granger causality, check the correlation and relation. Fourth is go to the VAR to know the impact of the past lagged variable with its impact variable. Then arch effect to know the risk and volatility. Grach effect to know the impact of external information and variance. Then co-integration. If I want to know whether the 2 stock prices are co-integrated or not, that can check through co-integration model or error correction model or vector error correction model. That is another part. Now, thank you very much. I try my best to explain everything within a short span of time, but I understand it will take more time to practice and grasp it. Thank you very much.
Thank you, sir, for your insightful talk. Now we can have one question answer section for some time. We have received many questions from participants, but due to short of time, I would like to take a few of them. Sir, one participant has asked, is it mandatory that all the series should be stationary at the same level to apply a particular model?
I got the point. Sometimes what happens, to apply the VAR model or Granger causality model, the series should be stationary, or error correction model also, the series to be stationary at the same level. But not necessary that all the series should be stationary, because now see, there are 4 different independent variables. How can you say that both will be? Sometimes it may be, but many times it may not be. So you have to check. Sometimes what happens, log difference will be stationary. I use that information. Sometimes difference of the variable is stationary. Sometimes converting the return price is stationary. So I should take the stationary based upon its characteristics. It does not mean that I will always take the fast difference and convert it to stationary. No. And it doesn't mean that all the variables should be stationary at level or equally fast difference or equally second difference. No. So it is the duty of researcher. Please go through the research paper, find out how that particular, listen, you can prepare meta-analysis also. There is one paper I have explained. He explained that GDP has taken 25 countries, and sometimes different countries having stationary at different level. So you have to find out when he taken the series of 20,000, 2001 series, when it is converted stationary in USA, UK when it's stationary, India in different period of stationary. So he explained that out of 35 research paper is taken, maximum says that GDP at the second level is stationary. So it may be, then he applies the second level to test. So it does not mean that all variables should be stationary at the same level, or it maybe depends upon the characteristics of the data. Yes.
Okay, sir. Another question is regarding, sir, you showed one ARIMA figure where it was 110, So the last figure was 0. So does it mean that residual lag?
There is no residual impact. It means that models is
Okay.
It means the model is the impact upon its own leg number 1, which is fast differences, but the residual impact is because residually all the characteristics residual are met. So it doesn't impact. There is no volatility in residual. There is no mean variation in residual, although there is no reversal variation in the residual. So that's why a moving average will be 0. Sometimes it may be happen. Okay.
Okay, sir. Okay. Sir, another thing also, in EViews, you showed one ARIMA model, automatic ARIMA model, where the specification you put as 4 and 4. So how did you select that figure? Is there any criteria to select?
No. Listen. That there is a default criteria. The EViews will take 4 and 4, but it is up to the researcher. If you have a good review on the ARIMA model of that particular series, you have know that how many auto-regression models that will significant. So some papers say that AR6 and MA6 will be more efficient estimator than AR4 and MA4. You cited that and estimate, but you can increase or decrease based upon your criteria and based on review. Listen, लोग बोलते हैं ना टाइम सीरीज एनालिसिस लेट मी कंप्लीट लोग बोलते हैं कि टाइम सीरीज एनालिसिस एक दिन में हो सकता है नो आई कैन एक्सप्लेन ऑल द टाइम सीरीज मॉडलिंग विद इन 2 hours from panel to regression. I can do that, but to analyze one model, I should have sufficient research paper to review that. What level, what significant impact, because I have to cite it, because I cannot take the model as it is. जब मैं डेमो दे रहा हूँ ना, तो I can use according to my mindset.
Yes, sir. Yes,
but
sir.
that mindset depends upon the review.
Yes, sir. We understand. Thank you, sir. Sir, is there any minimum number of years to apply Granger causality test?
Minimum years. Listen, I just forget to explain one thing. It is called sample. There is called population. Is it clear now? So more sample is more representative of the population. Similarly, in time series, one is called realization and another is called stochastic. Stochastic is the sample. Realization is the population. Okay, so if the stochastic level is very less in number, then it means sample may not be converted into population, may be biased. So what you will do, stochastic is a sample because it is a mean value of one particular series. So if you have taken the mean value, do not have all the realization value. So if you take the number of observations is very less, then there will be chances of error. The error there will be more. So if you take all the realization value instead of the stochastic value, then there will be no problem. Depends upon the research objective and review studies.
Okay, sir. Another question is, sir, you talked about a particular variable causes another variable, and we should write instead.
I'm not saying that particular variable causes Y. I say Granger causes.
Yes, sir. Granger causes. Yeah, you talked about that. So, what's the exact difference between causes and Granger causes?
Okay. Now, when you say X and Y, okay, X causes Y, what does it mean? GDP causes Y, inflation. इसका मतलब है inflation का impact GDP में है. But when you say the Granger causes, we will take the lag value. Whether the inflation as a level it will impacted or the fast, because when inflation as it is not impacted, it's some lag value is impacted. So we'll say the Granger. That's why the Granger uses the term Granger causes. If you write causes, then it will be wrong. The reviewer will say that it's wrong, written. And there is a beautiful paper on this, the difference between causes and Granger causes by one researcher from Switzerland. He said that if you use causes, this is your parameter. If you use Granger causes, this will be parameter. Then he compared between the causes and Granger causes, and beautiful meta-analysis paper he developed. We will go through that. Or I can give to the Chandrika Prasad, she will be said to all participants.
Yes, sir. Please, sir.
Do you require this PPT or not required?
Yes, sir. Yes, sir. Definitely. Sir, kindly, sir. Yes, sir.
Okay, I will say to the
sir, another doubt.
Yeah.
Yes, sir. Thank you, sir. Sir, another doubt is regarding VAR model. Sir, the T values in the VAR model, some values were in positive and some were in negative.
Listen, the fundamental concept, you always take the absolute value of T. You will ignore the sign of the T. Whether it's minus or plus doesn't matter. You always say that T should be greater than equal to 2. Okay, because if the left-hand tail, right-hand test already there is statistics. So minus and plus doesn't matter. It is the absolute value we always use. Because T, what is T? We say 1.96, we equivalent to 2. Okay, so actually 2 नहीं होता है, वो 1.96 होता है, but for provision हम 2 को लेते हैं. So minus and plus Doesn't matter, you take the absolute value. Thank you.
Okay, sir.
Any
Okay,
other
sir.
questions? There is a lot of questions, I think.
Yes, sir. There are a lot of questions, but
Ranjita, stop now.
okay, sir. Okay, sir. Okay, thank you, sir, for answering the
Do you have any
question.
question? You have a number of questions. Do you have any questions to answer?
Yeah, in one go, I think it is not possible to answer all.
Yes, sir. Yes.
So, thank you, Ranjita. So, thank you, Dr. Manoj Kumar Das. Actually, the session was very, very interesting and informative, and all of us, including all the, so all of us could be able to